Okay, so let's start now. So this is the uh, extra practice I got you all to go home and do yesterday. So I realized that there are some of the names that you all might not know. So I thought it would be good to actually go through with you because you are, as I mentioned, you are not expected to know the naming convention. You are not expected to, from the name, come out with the chemical formulas, or at least I should say the more complex names lah. Okay, so today the focus will be going through this worksheet 7 extra practice and then worksheet 8. Okay, that will be for today's lesson. Okay, come. Let's start. Okay, so first one, write a balanced chemical equation for your with full structural formula. This one means that actually all bonds must be drawn. Okay, all bonds must be drawn. Okay, all bonds must be drawn. Okay, in your structural formula. Okay, so for the addition of hydrogen to propene. So this is actually you realize, as I mentioned, for practice, extra practice worksheet 7, this is to practice on the addition reactions for alkenes. Okay, for alkenes. Okay, so let's start now. Arya, come first one. Because your name's like A, you realize we start with you. Okay, come, chemical formula for propene.
Like structural formula, right?
No, the chemical formula first. I just want the formula.
C4H8.
C4H8. Okay, Akid, is it correct or wrong?
Oh, wait, sorry.
Arya, come, try again.
Propene.
Yeah.
C.
Must get familiar with all the number of carbons, you know. So prop is what?
C3.
Yeah.
Oh yeah, sorry, C3H. 6.
6, correct. Because you're using the general formula CnH2n for alkene.
Yeah.
Okay. So I think you got the idea of the general formula is CnH2n. But it's just more like you must identify the number of carbons correctly lah. Okay. So I'm going to draw the structural formula. So first draw 3 carbons. Next, because it's alkene, I'll have a double bond functional group. Then next, I will just have the H around it. Okay. As mentioned, when you're doing addition reaction other than polymerization, I'll leave the bottom empty. Next, hydrogen gas, just addition of hydrogen. Hydrogen is just HH with a single bond in between. Now, so for this one here, addition of hydrogen, you know that it's 150 degrees Celsius with nickel as a catalyst. Okay, next one, Akid. So what will be the product? How many product will I get?
1.
1 product. How will the product look?
You break the C, the
Break-
double
Double
one. Then
one? Okay.
H below.
Oh, I realized I short 1 H here. Sorry, my bad. I short 1 H here. Okay, so this one here, what I'm going to do is I'm going to break the double bond. So let's draw the whole thing. I'm going to break the double bond. Okay, so double bond broken already. Then where will my 2H go?
The empty spots under the first 2 C's.
Okay, good. So this is your propene. Okay, Aki, just to finish up, after I add the hydrogen already, what will be my molecule of this product called?
Propane.
Yep, this is propane. So as mentioned, addition of hydrogen, actually you're converting your alkene to alkene. Okay, so just take note of that. Okay, next one. So this one here is gets a bit more complex, 2-methyl-butene. So I'm going to draw it out for you. So first thing, I'm going to draw butene. So 4 carbon. I'm going to draw the functional group. The 2-ene means that the double bond is in the middle. Okay. 2-methyl means that the methyl, there's an additional carbon branching out. There's additional CH3 branching out from the second carbon. So looks like this. Then after that, I'll just draw H. Sorry, I need to draw full structural formula, so I must show every single thing. Okay, as I mentioned, you don't need to know how to draw it based on the naming. You're not expected to know based on the names, so don't worry about it. So that's why I purposely want to draw it out for you. But for those of you who drew this correctly, good for you. Okay, so you realize I left the bottom empty as well. This is going to be addition of hydrogen. So it'll be like this with the 150 degrees Celsius and a nickel catalyst. Okay, so next one will be Austin. Austin, help me. Tell me what's the product that will be formed. Cannot talk. Wow. Good, you. Never mind. Next one, Kieran. Kieran just now can talk, so I know he can talk. Hey, Kieran, don't bluff. Don't say he cannot talk. Aiyo, Kieran. Master.
Yeah, what?
Yeah, what's the product that will be formed? How to do this? So think of what happened on the top, then you try to bring down the same situation. So what do you think will happen?
Take out that double bond and then put the two hydrogen under the
Yep, correct. So what you're gonna do? So good job, Kieran. So what you do is you just draw exactly the same thing first. So I'll draw the CHHH.
Mr. Eugene, if you draw the double bond in the first one instead of the second one, can also, right?
Cannot, because it's a build two in. So you cannot draw on the first carbon.
Ooh.
Okay, it must be at the sec. You see, there's three places that you can put the double bond, because it's built two in. That's why it must be at the second position. Make sense?
Yeah, okay, can. Thank you.
Okay, can. Okay, so this one here like that. Then I'll just draw H. Then I break the double. So there's a double bond here. I'll break it. Then after that, I'll draw a 2H at the bottom. Okay. So this guy here now is actually called 2-methyl butane. Okay, become very simple because there's no 2 in there because there's no functional group for the alkane. As I mentioned, you don't need to know how to name this one in particular. Okay, so for addition reactions, you don't really have to know how to name it. Okay, next one. Write the balanced chemical equation for the addition of bromine to pen 1 in, name the product form. So this one need to name, this one need to name. Okay, Joachim, formula for pen 1 in.
C5H10.
10, good. Okay, so I'm going to draw 5 carbon. Okay, good. Where will be the position of the double bond? Joachim.
At the first.
Can I draw at the last? Can I draw at the last one?
Yeah.
Can also. So
Either
first
one.
and the last is the same. Okay, good. So I'm going to draw pen 1 in. So this is pen 1 in. Okay, now I'm going to add bromine. So Br. Now there's no conditions for addition of bromine at your normal room temperature. You can, so your arrow don't need to draw anything. So the product form. Now take note, you need to name the product. So I'm going to draw the product out. Then I will ask Matthew, you try to name it. Okay, you don't name first. I draw it out first. Okay. So 5 H here, H here, H. Okay, so I broke the double bond. Then I put the Br here and the Br here. To give you a hint, let's call this the first carbon and let's call this the second carbon. This is still considered a pen something. Okay, so Matthew, now help me. What do you think is this fella called?
Like pen 1, 2, in
So what is the 1 and 2 here?
the position of the bromine.
Okay, so you are correct to use 1 and 2, correct? But this 1 and 2 here in between the A and E cannot. This is actually normally for the functional group. The Br is not considered a functional group. So this is still a pentane. Can you see it's still a pentane?
I know. Can I see?
Okay, yeah, what is this?
Is it 1,2-dibromopentane?
Okay, so 1, 2 dash dibromo, then pentane. Can? So this one, so what you know is that alkane is formed. So you write pentane. Then the position of the bromine, okay, you just need to indicate where it is. So this, because you add 2 bromine in, That's why it's dibromo. And then the 1, 2 actually tells you that it's on the first carbon and then on the second carbon. Okay? So this 1, 2 dibromo pentane. Next one. Okay, so this one just to save your, okay, save to your. So this build one in. So let's draw the 2,3 methyl build one in. So I show you. So I focus on the build one in first. So I got 4 carbon. Build one in means that the functional group is on the first position. Okay, so this build one in. I need to put a CH3 at the second and third carbon. So second carbon will be here. So CH3. I'm going to put on the third carbon another CH3. Okay, I'm going to put a CH3 over here as well. Okay, then after that, the rest I'll just complete with H. Okay, so this is actually your 2,3 methyl build one in. So you realize you do step by step. You will definitely use this in JCN. So the key idea here is to go from the main branch, which is the build one in. Then after they insert all the side branches. Okay, that's actually a technique to go about doing it. Do you need to be able to do this in an exam? Answer is no lah. They won't ask you such cheap questions. Okay, so don't worry about it. Okay, so I personally want to just show you how to do it, and you can figure out in the future next time. It will help you when you go JC. Add bromine like that. Okay, then once you have done this, I asked Matthew. Rehan, come help me. What's gonna happen here? Okay, I'm gonna draw the structural formula without the full. Can you tell me what's gonna happen?
The double bond, the carbon double bond breaks.
Okay.
And after that, below those 2 carbons, you put Br.
Okay, good. So I'm just gonna condense it further. I'm just gonna condense it for you. So CH2, CH3, 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 H. Is it correct? No, CH3, CH3. Wait. Okay, correct. Then down here will be a Br. Down here will be a Br. Can? Okay. Any questions for this one over here? Thumbs up if okay. Okay, good. Now, so what's the name of this fella? Your longest chain is still 4 carbon, so this will become from a one in to a butane. There's still the methyl group attached to the second and third position. So this will still have the 2,3 dimethyl group. So I realized I forgot to write the word dimethyl. Then there's also the bromine attached to the first and second carbon. So this will be a 1, 2 dibromo. So you can see the name of the guy is damn long. It's 2,3 it's 1, 2 dibromo, 2,3 dimethyl butane. Okay, you will need to learn how to name this and you go to JC. Okay, because you need to be able to name it and also vice versa. Okay, so at least you get used to the naming itself. Ken? Any questions for this one? Thumbs up if okay. Okay, Ryan, get ready, Okay, this one, Ryan, yay. Ryan, get ready, Now, formula for propene, Ryan. Simple one first.
Check this.
What's the formula for propene? Yeah. C what?
C3H6.
Yes, C3H6. So I'm going to draw propene now. Okay. I'll draw propene. Full structural formula out. I'm adding water. So what's the formula for water? Please tell me.
H2O.
Okay, H2O, good. Now see the way how I'm going to draw it. I'm not going to write H2O. I'm going to write H bonded to O, bonded to H. I'll draw this like right angle thingy here. Okay, because why? As I mentioned before, I'm going to split this to as my X. I'm going to split this to be considered as my Y. Okay, so later on it's easier for you to see. Okay, so with this, what are the two possible products formed. So I got A, I got B. What are the two possible products? Give me one of them, Ryan. If I add water, then what's going to be? Just give me a product. What's the after addition of water? What's going to happen?
Is it like the double bond will break, then you put below?
Yeah, okay. Double bond break and put below. So let's do the double bond break and put below. But what goes below? So now I show you how double bond break already.
H, right?
Then what is on one of them? What's on the other one of them?
So one is like H and one is OH.
One is H. The other one is OH. Can see? Okay. Now this is one possible product. What's the second possible product?
Second possible product.
So we can draw back the same thing. Okay. Once the double bond broken already, then what's going to happen now? What's going to go to the bottom?
Is it just those two switch around?
Yes, just those two switch around. Very good. Yay. Very good. So what's the name of the products? So I tell you what's the difference is the difference lies in the position of this fella. Okay. So this first one is added to the third carbon, which then if you reverse is the same as the first carbon. So this is actually known as a propan 1-ol. This guy here is actually known as a proper 2-ol because of the position of the functional group of the alcohol functional group. Okay. So whenever you got water being added or like an asymmetrical reactant added to the alkene, you can always get two different products because the groups can be added to the different carbons. Okay, you can just reverse or change the position of the other two. Okay? Okay, very good. This one. So this one over here, I'm going to simplify this for everybody. I'm just going to show, instead of writing CCC or everything, right? So just want to show you, this whole thing can actually be simplified to like that. Okay? This whole thing can be simplified to like that. At every position where there's a corner, right? Well, it means that there's a carbon over here. Then after that, H is assumed that if there's three different bonds for the carbon already, then there's one more H attached here. This only got single bond, this is H3. So this is actually one way you're going to learn how to draw when you reach tertiary education. So I'm just going to simplify it to like that so it's easier for us to draw. Okay? Now, you can't draw this in the exam. Cannot. Please draw this out in the exam. Don't draw what I drew. I'm just going to do shortcut here. Okay, after Ryan, let's go back. Arya, what is one possible product for the hydration of 3-methyl cyclohexene? Actually, the name not important. You can draw a thing.
Yeah.
What's hydration? Add what?
Add hydrogen.
Hydrogen. You sure?
I mean, HOH.
HOH, which is H2O water Okay. So you don't say water. Actually, this addition of steam. Oh yeah, sorry. Let's go back to here. I realized I forgot something important. Going back to question 5. Sorry, Arya. Pause for a while. On the arrow, you need to write 300 degrees Celsius because you need to write the condition. 60 atm, and then you need to write phosphoric 5 acid. So knowing the condition helps a bit in terms of the reaction itself. Okay? Okay, next, let's go back to here. Yes, what's the possible product that I can have?
Like CH3 at the top, and then
No, so let's focus on
the two CH, like you break it down into single bond.
Okay,
and
so double bond break to form single bond then.
And then one of the CH you can make it CH2.
Okay, so let's not draw the short form. Let's not draw short form. Let's draw it out for you. I think I draw it out short form after you explain. Everybody's so confused. I draw like that. Hey, I'll be hardworking and draw it out. Okay.
Okay.
CH. Okay, so like that. Then after that, double bond break. And then after that,
The CH, one of them can become CH2.
okay, so I just draw that. H jotting out. Then the other one.
Then the other one is OH.
OH. Then what do you think is the possible product too?
It's like the same thing, but then the OH at the top and then H at the bottom.
Yep. Correct. Very good. So let's draw out the thing. See. Kanchong. Okay, so this one here, CH, CH2, 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 CH, CH, like that. So OH at the top, H at the bottom. Okay, so these are the two possible products form. You realize they never ask you to name because you don't need to name lah. Can? Alright, don't need to name. Okay. Next one, let's go. The last one of this worksheet here. Okay, let's so after I ask Akid, give me the repeating unit for 7A. So do the repeating unit here, then the polymer.
Is the monomer without the double carbon bond.
Okay, so draw the monomer without the double bond. Like that.
Yes.
That's all. Correct?
Yes.
Wrong.
What the hell, man?
Often cannot talk. Kiran, come tell me what's wrong with the repeating unit. Kiran, what's wrong with this repeating unit? You break the double bond, good lah, but then what's missing?
Is it need the two things sticking at the other side?
Yes, you need the thing sticking out at the other side. Can? So, okay, remember, you need the two things sticking out on the other side. Okay, Kiran, continue. What's the formula of what's the polymer? The structural formula of the polymer. I help you first. You draw the repeating unit. Okay, then after that, Kiran, come tell me what to do next.
The bracket.
Alright, so I do the bracket. So take note of the bracket. Take note the lines will still be sticking out. And then after that,
The end.
and okay, good. Okay, Akid, I want to go back to you. Come, I'll let you redeem yourself. Part B, what's the repeating unit?
Monomer without the carbon double bond and the two lines at the side.
Very good. Okay, yes. Then what's the formula of the polymer?
Is the repeating unit with two brackets and an end.
Okay, two brackets at the end. Like that, correct or not?
Yes.
Okay, so must remember the lines must stick out, just remember. Okay, Kiran done. Okay, Joachim, this one here, what's the repeating unit?
You have to shift the left side, the CH3 below the first carbon.
Okay, then let's
Then
shift
you
it.
break
Let me
the double bond, yeah.
let me shift it first. Okay, then break double bond then. That's all.
Then you have the two bonds at the
lines.
side.
Okay,
Wait,
can?
Mr. Eugene, can you
Yes.
just, instead of making it like the H single bond C single bond H and then the one more single bond H, can you just write CH3?
Okay, so the question is, can you write like that? Instead of that thing out. Answer is yes, because they said draw the structural formula. If they say draw the full structural formula, means every single bond must be shown. Can? Make sense? Thumbs up, you okay? Yeah, so this one here, we don't have the word full, so it's okay to draw it like that. Okay, come, Joachim, continue, finish up the last one. Let's go.
The same thing, but you put bracket and then end.
Okay, same thing. Put a bracket and then end. Okay, so good. Now, common mistake, just remember, people always forget to extend out the lines. So depending on how strict the teacher wants to be, sometimes you just don't extend out, they will just minus your marks. Okay, so just be careful. Can? Okay, so we are done with this worksheet here. That's good. So let's do the next part now. Let's scroll down. Oh, sorry, let's pause here. Any questions for this particular part over here? Simple enough? All okay? Austin thumbs down. That means what? Not simple enough. Cannot. Austin can or cannot? Can. Okay, so I'm gonna skip this and let's go on to the last part of this worksheet. So if we end early, then we end early. Okay, so worksheet 8, the very last of this one over here. Now, so we covered alkanes and alkene reaction. Then what the crap exactly is this cracking? So in this particular last worksheet 18 here, we're going to learn cracking of crude oil. Key idea here is it's not an alkene reaction, it's not an alkane reaction. It's about obtaining the alkenes or the alkanes. So it's about making them. Right? The crude oil fractions actually are big chunks of alkanes and alkenes. But what is happening is that I want smaller chunks. So cracking is to make the smaller chunks appear. Okay? So we're going to learn what exactly cracking is. We're going to learn about how to determine the product and reactants of the after cracking. Then we're going to learn the importance points for cracking, and we're going to summarize the whole thing up with the similarities and difference between alkanes and alkenes. So this worksheet will wrap up everything quite nicely already. Okay, so let's start. What exactly is my cracking? So cracking, okay, so right now, cracking is the process in which large hydrocarbons, take note, must be hydrocarbons, are not organic compounds, large hydrocarbon molecules, okay, comma, usually alkanes, are broken down into smaller hydrocarbon molecules. Right? That's what cracking is. It's about breaking that large hydrocarbon molecule into smaller ones. Okay? Now, so the question is, why want to know cracking? So let's look at the context. Petroleum, which is your crude oil, okay, is a mixture of hydrocarbon that undergoes fractional distillation to produce useful fractions. So that's what we learned in the first and the second worksheet. So I think first worksheet, I think. Okay? But just take note, the heavier fractions are actually lesser in demand. So the demand for the heavier fractions are lesser. Think about it, the heaviest fraction, which is called, I just let you know, the heaviest fraction, okay, it's actually called bitumen. You don't need to know this, it's called bitumen. What the crap bitumen is used for? Is used to pave your roads. Now, if you think about it, how many roads you have to pave? You can't possibly, why would you want a lot of bitumen? You just need enough, right? So there tends to be a lot of bitumen left or whatsoever. And hence, what they normally do with this bitumen is that they know I maybe only need 10 tons. Okay? 10 tons of bitumen. But after fractional distillation, I got 100 tons. So what the other 90 tons they're going to do, they can't possibly just leave it there. It's going to be a waste. So what they do is they break down the 90 tons down into smaller fractions such as natural gas, such as petroleum gas, petrol, which is more commonly used for cooking, for cars, and stuff like this. Okay? So cracking is actually a very, very, very useful process. Okay, very, very useful process because it helps to produce the shorter chain hydrocarbons, which are usually also more useful. Okay, more useful. Okay? Now, so what are the conditions required for catalytic cracking? So, few things. First thing is high temperature. Okay, normally this will be about 500 to 700 degrees Celsius. In terms of pressure, don't need high pressure, just your normal pressure, 1 atmospheric pressure. And the last one, usually there'll be catalyst involved. Now, what's the catalyst you normally see is actually aluminium. Let me write down aluminium oxide. And so it's a combination, and silicon dioxide. So it's a mixture of Al2O3 and SiO2. Okay, in organic chemistry, there's a lot of these conditions to just take note of because without the correct conditions, actually the reactions will not occur. Okay, so that's why the conditions become important. Okay, so next part. So once we know cracking is to help to produce the more useful fraction. Okay, help to produce more useful fraction. Let's see how exactly it works.
Wait,
Alright.
Mr. Eugene,
Yes.
must we memorize the conditions for this one?
This one don't need.
Oh, okay.
Just know that it's high temperature with catalyst. The pressure is just high temperature and catalyst. Sometimes why am I writing this down? Because sometimes you see the past year papers, they might have the conditions written there and then thinking like, Archer, what's this? So it's because the older syllabus have it that you must remember. Lah. Can? Okay?
Okay.
Okay, so let's do this now. What's the general equation? So this is a general equation. So if you look in terms of definition, so the general equation is I will first have a long chain alkane. Okay, I'm going to have a long chain alkane. What I'll do is I'll let it undergo catalytic cracking. Catalytic cracking. So what's the process of catalytic cracking? Is to make it to a smaller chain, right? Now, you won't be able to know what the exact smaller chain is until they give you some of the examples, which I'll show you later. So long chain alkane with catalytic cracking is going to give you shorter, short chain alkanes. Now, it can be a mixture. So it need not be one. It can be a few short chain alkanes. Because in the reaction, you can't really say where you want the chain to break. So this reaction actually is quite random in a sense. You can't really focus on exactly I want a 5 carbon chain. I want a 10 carbon chain. You can't like that. They will just break it and then you'll just get a mix. Okay, but definitely they are shorter chains. So you get a mixture of short chain alkanes. Plus, okay, you're gonna get this one is alkenes, not alkanes. Short chain alkenes. Let me write alkenes. Okay, plus short chain mixture of short chain alkanes / hydrogen gas. So hydrogen gas can be produced from this reaction. So it's quite interesting. So it's either alkenes plus alkane or alkenes plus hydrogen gas. Okay? Now, so why is it important here? Is because as I mentioned, large chain alkane is like quite useless once I hit the demand of it. So there are other substances that are more in demand, other alkanes or alkenes that's more in demand. So cracking actually helps to produce these important products, which is first thing, of course, your shorter chain alkanes. Okay. And obviously the next one will be your shorter chain alkenes. And the last one is hydrogen gas. Now, what can hydrogen gas be used for? So hydrogen gas can actually be used for your fuel cells and stuff. So hydrogen actually is another source of energy that's being used as well. Okay? And the other function of it as well. So these are the 3 important products that you can get from cracking. Okay? Any questions so far? Thumbs up if all okay. Okay, so let's go on. Okay, so this is where the exam questions can come out like that. Okay, they tell you, okay, catalytic cracking can be done. They give you this setup here, and you can actually do it in the lab, which I don't suggest, because if you heat up petroleum with open flame, chances it might flammable, so it might get flammable. So we tend not to do this in the school. We don't have this experiment, so don't worry, you don't have to do this in the school lab. Yeah, but this can be done in the lab per se. Okay, so these are the equations here. And they say these are the reactants or products from the catalytic cracking. So let's look at part 1. I got the product here. What is the reactant that's formed? So you can see it's a single dotted line. Tells you that there's only one reactant that undergo catalytic cracking. What do you think is the long chain alkane on the left hand side? Rehan, is it your turn or is it Matthew's turn? Whose turn? Either one. Matthew first.
Wait, you asked about what again?
So what is this? What do you think is on this line over here? Think logically,
Like a longer chain.
Longer chain. So what is this longer chain? Tell me the chemical formula.
C10.
C10. H what?
C10H, like 14 plus 8.
22 lah. Okay. Can?
Yeah.
So this is correct. This is correct. So you realize it's very logical one. It's just the left must equals to the right hand side. Okay, so actually this is the kind of question that will come out. So it's a bit of a chemical equation kind of question, plus also your understanding of what actually catalytic cracking is. Okay, next one will be Rehan. Come help me, the second one. So
C6H14.
okay, C6H14. Realize the A question 1 and 2 exactly same. Yeah, it's exactly same. Okay, good. Next one, Ryan. Hey, take note of these 3 over here. How many carbon first?
Right, carbon. 11, right?
11? No, wrong. There's 3 C4H8.
Oh.
So must be. So C3, okay. H how many?
32 minus 24. That's what?
32 minus 24 is what?
It's 8, right? It's
8. Correct. Good. Ding. Good. Good. Okay, last one. Go back, Arya. Come. How many carbon?
There's no C.
No C. So C0. Okay, then
Yeah, so then it's just H2.
H2. Lah. So just to show you the hydrogen gas can be produced from the reaction. Can? Difficult? Not too difficult, right? So this is the idea that you need to get from cracking, plus also knowing the importance of it. Okay? So cracking is really just like that. But the process of cracking can get you alkene, can get hydrogen gas. And it's useful because it's from long chain, can become shorter chain. Okay, so that will be for cracking already. We are gonna go to do a summary of the alkenes already, just to wrap up the whole thing. Before that, thumbs up if all okay. If got question, you can ask now. Okay, so if no questions, then I'm gonna carry on to the last part already, the summary of your alkanes and alkenes. Okay, let's go. Let's start here. Okay, get ready. I'm gonna call on you to help me to do this particular segment here. It won't be easy because you don't know what the exact answer is. Just need to make a guess based on your current knowledge. So it's for you to dig out what you currently can remember, and that will be helpful for you to also recap lah. Okay, so let's start. Okay, first one. So just one minute. Okay, Asan, what are the elements that made up alkane and alkenes?
It's just hydrogen and carbon.
Carbon and hydrogen. Good. Carbon plus hydrogen. That's why they are also known as, what are they called? Asan?
Hydrocarbons.
Hydrocarbons. Okay. So, okay. Next one. Okay. Do they undergo combustion?
Yes.
Yes. Okay. If complete combustion, what are the products?
Is it carbon dioxide and water?
Yes. Okay. CO2 and H2O produced. Good. Okay. So you can realize by trying to dig out all this knowledge, it helps a lot. Next one. Kiran. Alkanes, are they considered reactive or not? I mean, they do undergo reactions, but are alkanes in general considered reactive?
No.
No? Then how about alkenes?
Yeah.
Yes. Okay, good. Ta-da! Next one, Joachim. What type of reactions do they undergo? The classification. So alkanes type S, alkenes type
Substitution.
substitution. Okay, so alkane addition. Good. So addition reaction and substitution reaction. So knowing the name is important because you are expected to know the classification. Okay, next one, Matthew. Do they react with aqueous bromine at room temperature and pressure? RTP stands for room temperature plus pressure. Okay, so room temperature and room pressure. So do they? Alkanes?
Alkane, no. Alkane.
No. Okay, no, then alkanes is?
Yes.
Yes. Okay, now tell me what's the observation? Bromine solution or what?
Observation. Like
Yeah. If you add bromine solution to alkane, what do you think you observe? How do you know that they don't react?
No visible reaction.
Okay, so no visible reaction is one way to say it, but in this case here, you know the color of the bromine solution, right? What is it?
Brown.
No. Add in one word before.
Reddish. No, that's
Reddish, correct. Reddish brown, correct. Reddish brown is correct. So bromine solution remains reddish brown. Can?
Yeah.
Wait, then what happens for alkene? This one I pause here. You next one, Rehan. Come, Rehan, tell me what happens to the bromine solution when I react it with alkenes?
It will turn from reddish brown to colorless.
Okay, turn from reddish brown to colorless. Good. Okay, why is this here? Because as I mentioned, they always like a test on this. So you realize by adding aqueous bromine, you can differentiate between alkane and alkenes. Okay? Ryan, help me last one. Do they undergo addition polymerization? Do they undergo polymerization? Alkane is what? Ryan.
Sorry. Alkenes. They don't undergo the polymerization.
Alkene is?
Alkene, alkene no.
Okay, so I need you to put here, don't just put yes. Put yes here and then put addition polymerization. Okay, addition polymerization, because under macromolecules, after we learn alcohol and carboxylic acid, you will realize there's a different type of polymerization that can occur. Okay, so addition polymerization is one of them. The next part, you're going to learn this thing called condensation polymerization. Okay, this one is not yet learned yet, so don't worry about it. You're going to learn it in the subsequent chapter for subsequent part. Ken? Any questions? Thumbs up if all okay. Not bad, you have survived all this worksheet already, so it's good. Tomorrow we'll carry on alcohol and carboxylic acid plus macromolecules if time permits. I'll be using your textbook for that one. Okay? Worksheet, as I mentioned, I'll give it to you after when school reopens. Okay, so let me stop recording now.